Hello, my name is Nick Bybee, and I am making this video to show you a fun and easy project that you can make with a myDaq and a breadboard that's actually very helpful in the world today. So this idea for my final project for the engineering class came from an idea that I had when I was little. When you're out playing as a little kid, your mom always tells you to come in when it's dark, but kids never know when it's dark. So I've created a circuit that will allow kids to know when it's dark, because when it becomes dark, it will turn on an alarm that will tell the kids, hey, it's time to come inside. So that's what I did. I used this, creating a photoresistor, a speaker, an LED, and 3 op amps. It's a very simple circuit. So here I'll show you the schematic real quick. So this is the schematic for my circuit here. As you can see, there's the 3 op amps here, 1, 2, and 3. Here's the speaker that it goes into, and I've also used 3 power supplies. One there, one there, one there. So how this circuit works is I start out with a 15 volt DC supply. So it goes in and it'll either connect with a 7 kilo ohms, so I've put that as 7 kilo ohms because that's the photoresistor, or a 6.8 kilo ohm resistor. So this photoresistor, I tested it, and this photoresistor goes to 7 ohms when it is dark, 7 kilo ohms. And I allowed current to go through by making a voltage divider here. So current goes into the op amps, and it's treated as the op amp is a switch, because Vp minus Vn equals the output times a very large amount. So when it's dark, it allows input to come in through this way. And I have a 5 volt supply as my rel and ground is my other rel. So if current is going through and it rels up top, it'll allow voltage to come out here, which will turn on my LED. So when it's dark, this LED will turn on. Now, the second part of the circuit actually isn't connected to this part. The second part is going through the LED. So I have another photoresistor right here. When this photoresistor gets light, it goes to 2 kilo ohms. And I have a 3 kilo ohm resistor right here, and I've also done voltage dividers here so that current can go through. So when this current gets light, it'll allow current to go through here. I've also reled it to 5 volts and reled it to ground. So when current goes through here, it will be the rel for this 3rd op amp. Now this op amp is a little different. I've put an AC voltage supply here. This AC voltage supply will treat this op amp as a buffer and will rel to the top when it gives it a rel, and on the bottom I've just reled to ground. So it'll go through here and it will signal this speaker to turn on. So that's kind of how it works. Now I'll show you the actual circuit. So here it is. I've used this flashlight signifying the sun. So this turns on. I have my photoresistor right here. A lot of confusing wires, but it's really just hooking it up. There's my 2 op amps, and in one of the op amps I have 2 of them, so that there's 3 op amps hooked up there. There's my LED. Turn it on and off there. There we go. Hooks to the second photoresistor, which goes into the speaker there. So we'll hook that up as the light there. And here it is on the computer. So this is the myDaq. This is the wave generator and an oscilloscope here. And so I've turned on a square wave, and I've turned it to about 600 hertz. And if I run it, it's letting 600 hertz through, but because there's light on my circuit, nothing's coming through. So we have sunlight. When the sunlight turns off, the alarm goes off, telling the kids it's time to come in. If the sun's out, the kids can keep playing. But when that sun turns off, it'll turn on the lights and the speaker, telling the kids that it's time to come in. So there's my easy circuit for you. I'll turn this alarm off so I can summarize here. But there's my easy circuit. It's very simple to do. 3 op amps, 2 photoresistors, a few other resistors to create that current, but basically very simple as long as you have that AC voltage and those 2 voltage supplies.